Hello everyone, today I will talk about our curriculum project that is related to numbers and operations unit of 5th grade. For our analysis, we use three theories that are Jean Piaget's theory of cognitive development, Vygotsky's sociocultural theory of cognitive development, and Bloom's taxonomy. Actually, there are many titles common for all programs in the beginning of the curriculum. But I won't give information about them, and I want to mention a little bit specific purposes of educational program of mathematics. According to curriculum, there are many special purposes of mathematics program. For example, it is expected that students can understand the concepts and they can use them in daily life and they can think mathematically, and while they are solving problems, they can express themselves freely by using mathematical language. We also mentioned the order of learning objectives about numbers and operations in the 5th grade level. These learning objectives are written under 6 topic titles, and there are 33 learning objectives in total. Mathematics is a way of reasoning and thinking with computation and measurement techniques by using the concept of numbers. Then we think natural numbers are the base of mathematics. Thus, natural numbers topic is the first topic in the 5th grade level. And fractions come after natural numbers, decimal points come right after fractions, and then the percentages. Also, we evaluated these objectives according to cognitive process dimension substeps. We saw that comprehension and application steps are used extensively here. For example, when we analyze the learning objectives where the cognitive field of comprehension is intense, we have seen that it's aimed to assimilate the concepts acquired at the level of knowledge, to capture its meaning, to interpret it, and to express the information with their sentences. In this part, we mention the comparison of objectives with previous and next year's objectives. All we know that most of the topics are divided into some subtopics in different levels in the curriculum because the curriculum is designed as a guideline that tells us which level of knowledge should be taught at that grade level. Because of that, we compare these divided objectives to see how connections are built into what they already know and what they will learn to create connections between prior knowledge and the new ones. We try to answer the question that how can we group objectives in general? When we analyze the curriculum, we can easily see the main points of the objectives, and they are grouped into two groups as you see. Let's look at the first one is that objectives link to others in previous and next classes. Here you can see an example of this. These objectives come from different class, but they link each other. How can this link be interpreted? We can say that most of the topics are divided into some subtopics in different class levels in the curriculum, and this division is aimed to facilitate the learning processes of students. Also, we know that they are partitioned and the next one is prepared as more complex than the previous one because children's critical thinking level is improved over the years as we see in the Piaget's theory. Also, the next year's objectives are required some backgrounds, information, and maturity to apply these, and they are provided in the previous year's objectives. We can say that the 5th grade objective as a bridge to make a connection between previous and next year's objectives. The second one is that objectives new concept here. You can see some new concept objectives. These give a base layer for the next year's objectives because these objectives are not related with the 4th grade objectives. Because of that, the comparison in this regard can only be made with the curriculum of the next year. For example, the exponents are also new concept for the 5th grade students in the subtopic of operations in natural numbers. However, when we compare objectives, we can see that percentages have different situation. It's a new concept for 5th grade, but it's not included in 6th grade, so we compare it with 7th grade objectives of percentages. Now, there's comparison of current curriculum with the previous two. It is separated to two parts, similarities and differences. Firstly, natural numbers, fractions, decimal notation, and percentages are included in the same order in all of them. Also, all three curriculums are prepared with appropriate words to Bloom's taxonomies. They use the words such as solve, classify, explain, solve. By using these words, the objectives in all curriculums aim to assess students. Lastly, the most important common feature is that they address the 5 strengths of mathematical proficiency that are understanding, computing, applying, reasoning, and engaging. There are some differences between current curriculum and previous ones. Actually, current curriculum and 2013 curriculum are almost same in terms of content, examples, and explanation under the objectives. But their difference is objectives. The objective for problem solving with natural numbers was added in the current curriculum. This objective is new in current curriculum. The differences with the 2009 curriculum are a little bit more. There are less activity examples that are procedural in the current curriculum. The importance is on conceptual understanding in the objectives of current curriculum. Finally, there are some topic removals in the current curriculum. The 2009 curriculum includes multiplication with fraction, ratio, and proportion, but they are removed in the current one. We discussed about numbers and operations objectives according to conceptual understanding and procedural fluency in this part. As we know, conceptual understanding and procedural fluency belong to 5 strengths of NCTM. We focus students' query activities with why question to analyze objectives according to conceptual understanding. For example, why am I doing this example literally? In addition, we find points where students develop strategy and reason to show procedural fluency. Let's look at one objective together. In this objective, students make reasonable estimates for addition and subtraction examples. They explain their own strategies and they can apply one strategy to other similar examples. When student encounters a different example, student is aware that her previous strategy is not suitable for the new example. To think one strategy appropriate for another example shows us procedural fluency.